In this lesson, we're going to look at a mix of problems for compound inequalities. Starting with number 18, we'll solve each inequality, graph the solution set on a number line, and express the solution set in both set builder and interval notation. What I'd like for you to do for 18 through 21 is try all of these on your own. Go through each one of them, practice on your own, and then go back to the OneNote and check your answer. Or if you want to, put it on a discussion board and discuss with your classmates. So solve each inequality, graph the solution set on a number line, and then express the solution set in both set builder and interval notation. So 18 through 21 are and inequalities, and we can see that because there are no words and we have two inequalities showing up in every single one. The other thing that I want to point out, notice that every single one of these, the inequality in each one of the problems is pointing in the same direction. And we've talked about this before, but we cannot have a three-part inequality where the inequalities are going towards each other, like they're pointing in opposite directions. Because if I were to eliminate the middle and one of the inequality symbols, what's left over would not be true. So we want to make sure that when we take out the middle, we still have a true statement. 6 is less than 8. -3 is less than 1. -3 is less than or equal to 1, right? So these inequalities, if we take the middle out, they're still true. So we have to be really careful. Only and inequalities could be written as three parts, but they don't have to be. And we've seen other examples of that before as well. So try 18 through 21 on your own. Take a look at 22. Why is 1 less than 2x plus 3 less than 9 considered a compound inequality? What are the two inequalities that exist in this problem? And what is the word that joins them? So we say this is a compound inequality because it has two inequalities in it. And the two inequalities are 1 less than 2x plus 3 and 2x plus 3 less than 9. We copy the middle over again. So 1 less than 2x plus 3, 2x plus 3 less than 9. And for this particular inequality, the word that joins them is and. And is the only word that is associated with that three-part inequality. So try the next set of problems, 23 through 25. Here, just like before, we're solving a compound inequality, but this time our compound inequalities have the word or. So 23, 24, and 25 all have the word or in them. So you want to take a look at those. Try them on your own, check your answers with the OneNote, or in your discussion boards. Let's do this word problem together. On the first of 4 exams, your grades are 70, 75, 87, and 92. There's still one more exam you're hoping to earn a B in the course. This will occur if the average of your 5 exam grades is greater than or equal to 80 and less than 90. What range of grades on the 5th exam will result in earning a B? We've got a lot of information here. So I have 4 grades. I want to earn a B in the course, and it tells me what a B is, greater than or equal to 80 and less than 90. If my average of the 5 exam grades is greater than or equal to 80. So we want to know the range of grades on the 5th exam. Average is a word that we use in statistics. It also means the mean or the middle of our data. To calculate the average of the exam grades, we'll take the 5 exams, add them up, and divide by how many we have. We have 5, so we're going to divide by 5. Let's write this down. 70, 75, 87, 92. There are my first 4 exams. The 5th exam has not happened, and we're in algebra, so we're going to add x to it. X is my 5th exam. This is what we call the average. Add them up, divide by how many we have. It says if the average is greater than or equal to 80 and less than 90, we'll get a B in the class. So let's see if we can solve this inequality for x. The first thing that we'll do is add up those numbers. 70, 75, 87, and 92, and we get 324. I don't like working with fractions. Let's multiply by 5 and get rid of it. We're working with a 3-part inequality, so whatever we do to the middle, we have to do to all of the sides. 80 times 5 is 400. Multiplying by 5 in the middle just gets rid of our denominator. 90 times 5 is 450. And now we can solve for x. Subtract 324 from all the sides. And we can pull out the calculator. 400 minus 324 is 76. We'll get x in the middle. And 450 minus 324 is going to give us 126, which is likely too high. So if we were answering in My Open Math Online, we would put these numbers in. 76 less than or equal to x less than 126. But in reality, 126, generally speaking, is too high. Very few instructors would have that much extra credit on a 100-point test. And I know it's not obvious in the problem that it's a 100-point test. Maybe I should have added that, but these are 100-point tests. So it would mean that that 5th exam would need to be between 76 and 100 in order to get a B. You could say 126 here. I'm going to be flexible, but just know in practical terms, between 76 and 100 is sufficient too. And that'll wrap up our lesson on compound inequalities. Remember, go back and practice those problems before this particular problem. Get some extra practice in before you work on the homework. The next lesson in this chapter deals with absolute value equations and inequalities. It turns out that all of this stuff we just talked about with compound inequalities, the ands and the ors, those are going to filter right into our absolute value inequalities. It turns out we need all of these compound inequality skills in order to solve absolute value inequalities.